Hi guys, today I want to go through historic models of the atom. So firstly, we're talking about the plum-pudding model. This was the idea that the electrons were sitting in a positively charged cloud, much like raisins in a plum pudding. But then in 1909, the gold leaf experiment disproved the plum-pudding model. Basically what you do is you get a very thin piece of gold, about 1,000 atoms thick, you find alpha particles at it, and about 1 in 8,000 of these alpha particles are deflected. And the reason why they're deflected is they'll get so close to the nucleus if they hit it head on, because the alpha particle is positively charged and the nucleus is positively charged. The alpha particle gets hit back off the nucleus. And because the nucleus is so small, this is quite a rare event, so this is why only 1 in 8,000 times this happens. So basically you got the idea that the gold leaf experiment basically showed that the nucleus must be incredibly massive. Basically all the mass of the atom is inside the nucleus, yet very, very small. So just like a solar system kind of model, the electrons are kind of orbiting the nucleus, and about 99.99% of the atom is, very bizarrely, empty space. The problem is, though, as the electron orbits around, it should emit radiation, and with that emission of radiation, electromagnetic radiation, it will lose more and more energy, and eventually it's going to crash into the nucleus. Bit of a problem, because that is not what happens. So as the electron orbits the nucleus, it will emit electromagnetic waves. The electron will lose energy and crash into the nucleus. And this doesn't happen, so something else must be going on. And this finally comes up, we end up with the Bohr model. So in the Bohr model, the electrons can only exist in specific energy levels. They are quantized. They can't exist in between these energy levels. Electrons are forbidden to exist between these energy levels. Now, what's the evidence for this? Well, the evidence comes from something called emission spectra. So the emission spectrum of an element is the spectrum of frequencies of electromagnetic radiation emitted due to electrons making transitions from higher energy levels to lower energy level states. So here, normally if you heat something up, the spectrum that comes off, like if you heated a piece of metal, you get a very broad range of spectra. You know, you get light, just like, I don't want to say the word rainbow because lots of people get angry, but basically like a complete spectrum, all different colours. But if it's an ionized gas, only very, very specific frequencies of light are seen, and that's due to the electrons jumping from higher energy levels to lower energy levels, and every time they jump, a bit like jumping down a flight of stairs, you can jump from one step to another, it's always the same distance and height, so as the electrons jump from one electron level to another, they will emit the same frequency of light every single time. Okay guys, hope that's been useful. Bye for now.